Math 20 in the PM. I'm your host, Mr. Shindalka. We got rate of change here, 1.3. Okay? Psst. Thanks. Attention. So, just a cotton picking minute. I got the wrong. Did I do this? Yeah, I did. Okay. No. Because I'm almost teaching the same stuff with the 30 levels. I'm getting mixed up which is which. Anyways, slope. Using coordinates to calculate slope. Slope is how steep something is, right? Now, here's a formula. Any 2 points, you always give them in order, the x value and then the y value, and more about that in a second. But this is the important thing, and that's why I've circled it for you. Slope is given by this formula. We use the letter m to mean slope. y2 minus y1, and this will make more sense once we go through an example. y2 minus y1, then x2 minus x1. Now, how do we do that? Well, let me just flip a roo here. And sorry guys, I'm just trying to flip this. There we are. Well, let's see how this works. We'll work through this. If a line on a graph rises from left to right, as in this following graph, it's going up from left to right, we say the slope is positive. Okay, that's what we're talking about there. Now, if the graph goes down from left to right, the slope is negative. So it's going down from left to right, because the rise is actually going downward. So first of all, there's nothing to do on this first page. It's just some ideas. Going down from left to right, it's negative slope. You'll get a negative value in this. Now, that formula though, how do you use that? Well, let's flip this page. Okay. This is the same formula I circled on the other page, right? You're going to need these formulas here, always. So, I'm going to put that one down there. Consider each of the following graphs. Are the slopes positive or negative? Then calculate as a fraction. Meaning you don't have to get out your calculator and do decimals. So this one here, from here to here, from dot to dot, is that positive or negative right off the bat? From left to right is going up. Positive, right? Okay. Now, that's the first thing we decide. So it's positive slope. I'm going to just put m is plus. Okay, that's all. M is what we use for slope. Don't ask me why it's the letter M. But S must have been used up. You know, maybe they didn't invent the letter S when they were doing how to use it. There's a reason, I'm sure. That is. Okay. Next, we have to calculate each slope as a fraction. That means we need to know how to read this point down here and this point down here. How do we do that? Well, do you guys see, this is what we call the x-axis. And do you see that it's like going straight down from the dot? It is 1, 2, 3 over. So always do the x first and say that's 3. And this is 5 high. So 3 comma 5, because the dot is at x equals 3 and y equals 5. Can I give you guys a second here to do this point here, what its x and then y value is in brackets? And then we'll work on the formula in a second. Now this isn't going to take you long. So Gerald, do you have an x comma y for the higher point? Nope. Okay. Shana does. Yep, 6 comma 10. Okay, that looks good to me. Now what? Well, I'm going to try using this formula to calculate the actual slope. Okay. Now, I don't care which one you call 2 and which one you call 1, but I tend to number things from left to right. So, if I call this my first point and this my second point, you don't have to actually label that on there, but that's the way I'm thinking, so I'm going to write that down. Then, I'm going to use this formula here. What is my y value for the second point? That's what y2 means. So what's the y value in the second? It's 10. Okay, so I'm going to put this 10. So I'm going to go like this. M equals, and I'm going to take this 10 and put it in place for y2. So I'm going to call this 10. Does anybody have a question about where I got this from? Why I'm putting that in place of y2? Then, while I'm at it, you notice right underneath it in the formula, I'll wait though. Looking up. Okay, take a look at there. You see in the formula right underneath y2, you got the x2, eh? So I'm going to put this x value from the second point there. 6 is my x2. So that goes right in this spot. Now, where did that come from? Everybody's clear on that or not? Yeah? Because if you're not, do ask, because it makes life impossible. Then what? Well, y1 and x1 on the other half. So now I'm going to look at, I'm going to look at this part, right? The minus part. y1 and x1. For my first point, the y value is 5, and x1, or the 3, is the x value. Does everybody make sense out of that? Or I'm getting it? So I'm going to take the 5 and the 3 and put them in there. Then all I got is arithmetic to do. I'm using different colors just so you can maybe have a better idea of where things came from, right? Maybe next time we'll do you one better. You'll see. So, the arithmetic is 10 minus 5. I'm hoping at this point you guys know how to do arithmetic. M is equal to 10 minus 5, so that's 5. 6 minus 3, so that's 3. We were asked to leave your slope as a fraction. Is that fraction though in smallest terms? Good for you. Glasses. Yes. Okay. So this is a finished answer. Fractions are just fine. Let's go through the next one here together. And here's what we got to do first. Is this positive or negative from left to right? You guys know what we're asking just by a quick glance? Gerald? From left to right, is this going down or up? Down, so it's negative. The slope is negative. That's the first question. M is negative in this case. Now we'll actually calculate it and you'll know why you get a negative answer then. So I'm going to use two different colors for this. My first point over here, what is the x value at this point when it's right on the line? Tatiana? You're not sure? Okay, well you go down to the x-axis and read off the graph there, it's a 0. And then it's sitting at a height of 10. I'm going to use 0, 10 right there. Then, the second point. Can you come up with your x value and y value for that? Justine, do you have an x and y value for this point right here on your sheet? Take a look. So what's the x value? 9, yeah. 9, comma, and then the height is 5. Okay? Now, is there any questions about how to come up with just the ordered pairs? They have to be, and they're called ordered pairs because they have to be in order, x then the y. Okay. Now, let's look at this. This formula says m equals. This portion, we'll look at the second pair, and then we'll subtract the other pair, right? You guys follow what I'm getting at? Okay, so I'm going to say m equals, and I'll keep the colors consistent, just so that you know where things came from. So what I'm calling my second point is my green numbers. My y2, I'm going to use 5, and I'm going to use x2 as 9. My y1 is 10, and my x1 is 0. Now, are we good with where I came up with all this? There's a lot at once. Are you? Do you see where this came from? Okay. Would you tell me if you did? You would. I'll trust you. Okay. So 5 minus 10. You do that one in your head? Kevin, keep working, Kevin. Sorry. Gerald. Yeah. 5 minus 10. 5 9. Pardon? 5 9. It's 5 9 almost, but this is the part where people would make a mistake. It's negative 5, because 5 minus 10 is actually negative 5. You're subtracting more than you started with. So negative 5 out of 9. That's your answer. Had to have a negative sign in it, as we know, because it dropped. That's because 5 minus 10 is, it's 5 degrees out one day, and then it drops 10 degrees the next day. We're at negative 5. Anyway, make sure the signs are included. When you have assignment work time, that'll come up. Okay, any questions before I flip her? Okay, I will. I'm going to do this one with you because these are the two trickiest. Kind of like they're not at an angle, are they? L1 and L2 have two different slopes here. L1. Let's try this slope thingy here. Slope is equal to, y2 minus y1. Now look at this. These ends, that's L1, right? What are the two ordered pairs there? You get a chance to do the ordered pairs there and there. And then calculate the slope. I'll give you guys a minute to calculate the slope for that one. You need a calculator for this one? What do you got on the top? What minus what? I'll just walk. Do you have your numbers? What do you have on the top here? I'm sorry? Yeah. I'm not going to make fun of you. What do you have? Okay. What did you have right off the bat? What minus what? What's your y2? Did the 2 and the 6 together? Okay, the y is always the second value, right? So, try this. Give it a second here. There's no doubt that you're trying to avoid me, you're not sure. You are. Okay, which of the two y values just do? 6. The y value here is 6, and what's this one? 6 minus 6. And then the other one. the same order. x2 is 9, x1 is 2. Did yours start out like that? No? Okay. Do you want me to go over how this is done? No? Okay. I will later if you need. Now, on the top, what do you get? 6 minus 6, it's 0, right? 0 out of 7. But what is anything out of, or 0 out of anything? It's just 0. No. So, there's a shortcut for something like this. If you see a flat line straight across, does this rise at all? You just ask yourself, no. So we say the slope, how steep is it? 0, it doesn't work. Whenever you have a flat line, horizontal line, you can just skip the word. From now on, you have my permission and just say it's 0. Oh, I didn't mean to do that. Now, what about the other line? And I'll do that one with you real quickly, because it's a similar one, but it's a little, I'm saying similar, it's not the same. It's different. I'll just leave all these things in. Just moving this space for the other problem. So now, let's get something more fun than this. Let's go psychedelic. So, L2. The second line is the one that goes straight up and down. I'm going to just follow along with this one. You see that this has a height of 9, so and the x value is 4. So I'm going to put down, use green for this one. 4 comma height 9. And this bottom one here is 4 comma height of 2, x comma 1. So, move that over here. I need that same formula. And so that m is equal to the y value is always the second part of the bracket. You see how this is always, it's always x comma y? So the second, 9 minus 2. I'm sorry, what's that? I'm going to come over here. Does that help? So, here's what I'm trying to do, this formula here. y2 minus y1. The higher point I'm going to call 2. So 9, because it's 9 high. Minus the second, or the 2, I mean, over there. Okay? So I'm saying 9 minus 2. And then the x values are both 4. So on the bottom there, x2 minus x1 turns into 4 minus 4. That turns into 7 minus 4. Or 7 over 0. I'm sorry, 7. But 0 on the bottom. And here's a problem. Can you divide by 0? Try it on your calculator if you wish. You can't, though. It'll say error. Okay? You can't have this. We call this an infinite slope or undefined when it's straight up like a rocket. Why? Because there's a rise, but there's no run, no sideways part to it, okay? So we'll just say, if you want to put undefined, UND, that's quite common. Some people put infinity because it goes up infinitely fast. There's a number of ways, but undefined is fine. As long as you explain something like that to me. Now, am I okay to slide a little bit? Okay. On the graph below, show me a solid line that passes through A, that's the dot there, and has a slope of 6/5. That means the rise is 6 and the run is 5. So I'm going to give you guys a minute to try that and then do the second one. You'll notice that there's a negative sign, so there's a drop of 3 over a run of 2. Okay? And you don't need a ruler. You should be neat and try to make it straight, but up 6 over 5, up 6 over 5. I'll give you a minute. Do it both. You got it. Okay. So the first one, I think you might have missed. Take a look at how I do it. So with this first one, I'm going to say we start at dot A, right? Take a look. If the rise is 6, right, and the run is 5, that's what this is telling me, right? Well, that goes up 6, 1, 2, 3, 4, 5, 6, and then over 5. 1, 2, 3, 4, 5. Does it make sense how I got my second dot? Now I'm going to join them with, it says, a solid line. So I'm going to go to my lines, and I'll use a solid line. So there you go. It said it passed through, so it can go backwards. Just fine. If you're a real crackerjack, you put little arrows at the end. Say it goes forever. What about B? Did you notice that the rise in B, let's take these down. There's a minus sign in front of it, so it's actually not a rise, it's actually a drop of 3, so down 3. So I'm taking from point 8, you go 1, 2, 3 down, and over 2, 1, 2. So you connect those dots with a dotted line. Now, if you accidentally use a solid line, fine, but the whole idea is, I'll get it straight. Seeds from the shadow. There we go. Your lines should look something like that. And they can go off the grid a bit. Yeah, Homer? Okay, I'm going to just see here then. I'm going to flip. Tell you what, try working on something else just because I should finish this first. And then, yeah, because I got one last thing to look at. Okay, last thing. Working with slope is a rate of change. Like speeds are rates of change. How fast you're going, kilometers per hour. Things. Like 50 kilometers per hour for any length of time. You'll have traveled 50 kilometers in 1 hour, 100 kilometers in 2 hours, 150, you know how that adds up, right? Most people estimate when they travel that they're going 100 kilometers per hour, right? Because if I say it's 550 kilometers to get to Winnipeg, how many hours will it take you? if you didn't have major stops for meals. 550 kilometers, what do you think? Going 100 kilometers per hour. Oh, help me. 5.5 hours, because you're 100 kilometers every hour, 200 the next hour, 300, 5, 10, 15. Counting like that, counting the 100s. Okay. So, you can plot these rates on a graph and stuff. So we're given two rates. You're going 50 kilometers per hour, and then the other guy's going 75 kilometers per hour. Now this is done for you as an example. But you see the solid line. If you start out at time 0 and you go 50 kilometers in 1 hour, that's the way I count it there. Okay, good. The next hour, up 50 over another hour, up 50 over another hour. Do you see how that goes on forever like that? Up 50 over. That's really the slope. How about the guy who's going 75? He goes 75 kilometers for 1 hour. How about the next hour? Same speed. 75 kilometers up higher for another hour. And so on. If you trace this, even though the dots aren't there, he's going up 75 over 1 hour every time. You can find the slope by looking at any spot on the graph. Now, that's what this next statement says here. Pardon me. Now, there's something here just from problem solving I'm not going to get too worried about, but there's an independent variable and a dependent variable. You guys all know what the word depend means. How far you've gone if you're driving in your truck, other than how much gas you have and stuff like this, doesn't it depend on the amount of time you've been driving 100 kilometers per hour or 50 kilometers? So time is independent because the distance you've traveled depends. Distance is dependent on time in the vehicle. Does that make some sense to you? Kind of? You'd say, well, how far have I gone? That depends. Were you in the car? Did you guys drive for 2 hours? At 100 kilometers per hour, you went 200 kilometers. That's what it depended on your time. Now, I didn't go into, like this one's not a working example or whatever, but just to give you some ideas when you're solving problems, speeds are really just slopes. And you can come up with the equations in a distance, whatever your speed is, times the time. 50 times, the hours, the t. That's what that's all about here. But tell you what, I won't hold you back because I think give these questions a try. You guys got 15 minutes right now to work. You have time tomorrow to work on this stuff. I want to come around and see a few people today, though, too. Okay, I'm going to stop the recording. Is there any questions, though? You got stuff to work on? Good. Here we go.